It is math time, my bros.
Alright, let's start with something simple. I assume your first thought is just, oh, just rationalize it. Multiply it with the square root of 2 over square root of 2. What if I said there's an easier solution? See, square root of 8 over square root of 2 is the same, yes, the same as square root of 8 over 2. Who woulda knew? So now, it looks easier. And it is actually. So what's 8 over 2? That's 4. Don't forget the square root. Now, 4, as we know, is 2 squared. I assume you know. You better know. So, we can now say it's 2. Because 4, square root of 4 is 2. Alright, that was pretty easy, right? Alright, let's move on. Right, problem number 2. It's time to simplify. 32 and 6 are both divisible by 2, which is just fancy words for can be divided by 2. So what's 32 divided by 2? We get 16, and 6 divided by 2, 3. So now we have square root of 16 over 3. We're not done here, not just yet. So we can convert it back to square root of 16 over square root of 3. Now, you might think that I'm being counterproductive, but as you can see, square root of 16 is legible. So, what's the square root of 16? 4. Over 3. Now we can rationalize it. And we're done. That's the final product. We can't do anything about this square root. As much as I'd like to get rid of that, we can't do anything about it. Alright, next. We can take this methodically, one by one, baby steps, you know? So, again, we can convert this to this. But did you know you can also cut it up like this? So again, baby steps. So we're gonna tackle these one at a time. Let's start with 75. Here's a trick I learned when dealing with imperfect squares like 75. First, let's try dividing it by 2. We can't without getting into decimals, and we don't want to complicate this any further. So let's try with 3. 75 divided by 3 is 25. Now, so we have 25. Would you look at that? 25 is a square of 5. So we can now write 5 to the side and leave 3 in the square root. Because we can't do anything about 3 without getting into decimals, which we don't want, remember that. So, next, we have x squared. Just take the square away because x squared, the square root of x squared is x. So let's put that next to 5. All of the roots should be in one side only. Now we have 48. Divide that by 2, 24. That's not a perfect square, so let's try number 3. Now it's 16. What's the square root of 16? 4. Let's put 3 to the side again. Now we have y to the 4th power. 4 divided by 2. We have 2. So it's y squared. Z to the power of 3, or z cubed. It's technically just z squared times z. Now, we can take z squared away from his pathetic little brother here. I hate you. And then we can toss that boy aside. It's the square root of z squared, z. Let's put him here. As you can see, both top and bottom have the square root of 3, so they cancel each other out. Now we're left with 5x over 4y squared z. Square root z. So as we all know, we have to get rid of all radicants at the denominator. This is just fancy word for bottom. So you can use that the next time you're in bed. That's some lingo there. So let's rationalize. 5x square root of z over 4y cubed z cubed. Anyways, Thanks for watching.